queue implementation using array. Queues can be easily represented using linear arrays. As discussed before in the previous videos, every queue has two variables, front variable and rear variable. So here the front variable and rear variable would be pointing to the position from where the deletions and insertions can be done. To implement a queue using an array, the very first step is create an array of size n. So we have to define the size of an array. What should be the size of an array must be defined prior, and the second step is take two variables front and rear, initialize both variables to 0 or -1, which means the queue is initially empty. When it is empty, both front and rear would be pointing -1, which means the queue is empty. And when it comes to the elements, there are two variables we are going to use, a rear variable as well as the front variable. Rear variable is the index up to which the elements are stored in the array, and the front would be pointing the index of the first element of the array. For example, if you take this example, the rear is pointing the last element. The array size is 10. The array size is actually 10, which means array can hold up to 10 elements. Array means the queue has been implemented using the array structure, which means the queue can hold up to 10 elements. But if you check, there are only 6 elements are stored inside the queue, right? And the rear is pointing the last element, which means rear is the index up to which the elements are stored in the array is what the rear pointer is. So the rear is pointing the last element in the queue up to which the elements are stored, the index up to which the elements are stored, and the front would be pointing the first element of the array. So front is the index of the first element of the array. These two pointers are important, these two variables are important. And when it comes to the operations, there are two basic operations, NQ operation and DQ operation. NQ is insertion, DQ means deletion. Let's discuss the operation one by one, and also will write the pseudocode for the same. The first operation is insertion, algorithm to insert an element in a queue, and example queue structure has been given here. This is the existing queue structure and this is empty queue structure. For this existing queue structure, the queue size is 10 and here the queue size is 5. Let's start writing the pseudocode to perform insertion, and along with the front and rear variable, one more variable we are going to use, which is called a max, which means the maximum number of element the array can hold or queue can hold. So the array size given here is 10, which means maximum up to 10 elements our queue can hold here. Let's start writing the pseudocode now. The first condition is you have to check whether there is overflow condition occurs or not. Overflow is nothing but when there is no space to perform the insertion operation, which means that there is an overflow condition. When the array is completely full, when the queue is completely full, we won't be able to perform the insertion operation. So first we need to check whether there is a space to insert an element or not. We have to check. So if overflow condition doesn't appear, which means that there are space in the queue, we can perform insertion. We can insert a new element into the queue. So the first condition is if rear, because when it comes to insertion, always insertion would be performed only at the rear end. So we are checking only at the rear end when it comes to the insertion. If rear is equals to max minus 1. Suppose if rear is pointing max minus 1 means there is no space, right? Right, overflow. Here the max is 10 because this queue can hold up to 10 elements, right? Suppose if rear is pointing max minus 1, max is 10, 10 minus 1 is 9. If rear is pointing the 9th index means what? The array is completely full, right? The queue is completely full. We cannot perform insertion operation. So it has to print overflow, which means that the queue is completely full. No more insertions can be performed in the current existing queue. Otherwise, if you check the rear pointer, our rear pointer is not equals to max minus 1. Our rear is pointing only 5th index only. It is not max minus 1, which means there are spaces left to perform insertion, to insert new elements into the queue. And the next condition is you have to check whether the element, just for instance, I want to insert a new value which is 35 into the queue. The new value 35, the data element 35 I want to insert into the queue. Now you have to check whether the value which you are going to insert is going to be the very first element in the queue, or already there are elements, your element is also going to be one of the elements in the queue. You have to check. The condition is to check whether your element is the first element or not. The condition is going to be if front equals to minus 1 and rear also is equals to minus 1, which means the queue is completely empty. The element which you are going to insert is going to act as the very first element in the queue. For example, you take this queue structure. You imagine this queue structure is completely empty. When it is completely empty, our front would be pointing -1 and rear would be pointing -1, which means front and rear is equals to null because there are no elements in the queue. So, front and rear cannot be pointing any index position here. So, we have initialized the front and rear with a 0 initially, especially when the queue is empty. So, if front is equals to 1 and rear is equals to 1, which means if the queue is completely empty, take this queue structure. When the queue is completely empty, you are supposed to set both your front and rear equals to 0, and finally in the place of rear, after setting up front and rear equals to 0, in the place of rear you can insert the value, the new value which you want to insert. So, you can set front as well as rear equals to 0, front as well as rear equals 0, which means front and rear would be pointing the index 0, and then in the place of rear you can insert a new value. The value which I want to insert is 35, I can insert the new value 35. So, now both front and rear would be pointing 0. Else, suppose already there are elements, check this queue structure, there are already elements. If there are already elements, some other condition we are supposed to follow. Simple, set rear equals to rear plus 1, and in the place end if, set rear equal to rear plus 1. Now, rear is pointing 5, I am going to set rear equal to rear plus 1, rear plus 1 is 6, 5, rear is 5, 5 plus 1 is 6. Now, my rear would be pointing here. After incrementing, after executing this step, after executing rear equal to rear plus 1, rear would get incremented to the next position, and now in the place of rear you can insert a new value which you want to insert, which is 35. So, if you want to perform insertion, simple, you can increment the rear position one step and you can perform the insertion. So, in a queue data structure, if you using an array, if you want to perform insertion, it is similar to the pseudocode of the insertion, performing insertion at the end in array structure. Same pseudocode we are supposed to follow here for the queue here also when it comes to an insertion. So, if it is empty, front is equal to -1 and rear equal to -1, we are supposed to set front and rear equals to 0, and then in the place of rear you can insert a new value which you want to insert. Suppose already there are elements, in that scenario simple, you just simply, if your front and rear is not pointing -1 means simply increment rear equal to rear plus 1, and then in the place of rear you can insert a new value. That is it, right? After performing the insertion you can exit the pseudocode. This is how we are supposed to perform insertion. So, if you check here, initially the queue was empty and we performed insertion 35, right? Now, we want to insert a value 40. Let us trace the pseudocode, whether rear is pointing max -1, no, rear is not pointing max. Check this queue structure, I am discussing with this queue structure, queue example only. Check whether rear is equal to max -1, no, my rear is pointing 0, rear is not equal to max -1. So, underflow condition does not exist here, and check whether front equal to -1, rear equal to -1, which means the element which you are going to insert now, the 40 is going to act as a first element in the queue, no. So, first condition also fails here. So, go to the else part now. In the else part, simply if it is not -1, simply you just increment rear equal to rear plus 1. Rear equal to 0, when you increment to the rear, now rear would be pointing here. Rear was initially pointing 0, now rear would be pointing the index position 1. After incrementing the rear pointer, just end if and implement this statement, execute this statement, queue of rear equals to value. Where is rear? Rear is here. In the place of index position 1, the new value 40 you can insert over here. Again, if you want to perform insertion, increment the rear position, in the place of rear you can keep inserting the new value. This is how we are supposed to perform insertion in a queue data structure using array. And there are two cases which you are supposed to check. The first case is if the queue is empty, this is the condition. These two statements we are supposed to execute. If the queue is not empty, there are already elements, simply you can increment the rear, and in the place of rear you can insert the new value. Next, how to perform deletion from your queue. When it comes to the queue structure, always insertion can be performed here only at this end, and deletion can be performed only at this end, which is the front end, right? So, when it comes to deletion, always you need to focus on the front pointer, not at the rear pointer. Let us start writing the pseudocode. The very first condition is to perform perform deletion, you have to check whether there is an element in the queue first or not. Only if there is an element in the queue, you will be able to perform insertion. If the queue is completely empty, no more deletions can be done here, right. So, first you have to check whether underflow condition occurs here or not. To check for the underflow condition, the condition here is if front equals to -1 or front is greater than rear, which means if front is pointing -1, which means when there is no element in the queue, front would be -1, right, which means the front is equals to null. In such scenario, we are supposed to print underflow, and otherwise go to the else part. Let me explain this statement also. If front is equal to -1 means the queue is empty. If front greater than rear also, the queue is empty only. For example, let's take this example. You are deleting, do you want to delete it? Let me write the else part also, and then I will discuss this condition. When front is greater than rear also, how it is going to be empty, let me discuss later. Now, if it is not empty, if it is not underflow condition, simple. Since the deletion can be performed only at the front end, look at this example. Since the deletion can be performed only at the front end, simple, we want to just ignore this. We want to just delete the first element, right, because only at the front pointer the deletion can be done, right. Before you simply ignore this value, or before you simply delete this value, you just create one temporary variable. Under the temporary variable, you can store the value which you want to delete, because for future purposes, if you want to use, you can use it, right. So, you are going to fetch the value which is there at the front position, with front index position, and store it under the temp variable, and then you can delete it. Deletion in the sense what? Changing the index position of front. Front equals to front plus 1, that is it. After incrementing the front, now front would get incremented to here. Front was initially pointing 0, now after incrementing 0 plus 1, front would be pointing the first index. So, front pointer would be pointing 1, which means the elements, the data elements would be considered right from the first index till the rear pointer, which is the 5th index, which means we are ignoring the data element which was there at the front pointer before incrementing it. Now, we just incremented it. Now, right from the front till rear only the elements would be considered. So simple here. You just fetch the data element which you want to delete and store it under the temporary variable, and then increment to the front. Front equal to front plus 1, end of if, and exit the pseudocode. That is it. This is how we are supposed to perform deletion using in a queue data structure using an array. Now, let us discuss this condition also. Front equal to -1 means we know it is empty. When the queue is empty, our front would be pointing -1. When we will face this scenario, front is greater than rear. For example, I am checking here, okay, I am implementing, like I just want to take this example and I want to perform deletion now. I am just checking whether my front is equals to -1. No, my front is not equals to -1. So, we can go to the else part. In the else part, if you check for the condition, we are supposed to fetch we are supposed to create one temporary variable temp. Under the temp, we are going to store the value which you want to delete, right. So, under the temp variable, I am fetching this value and stored it under the temp variable. After storing it, I can simply just increment my front pointer. Now, after incrementing it, both my front and rear would be pointing this only, right. Both my front and rear would be pointing the index position 3. Next, again trace the pseudocode. Again you want to perform deletion. Whether your front is equals to -1, no. Whether the front is greater than rear, no. Front and rear is equal. So, it is not underflow condition, which means you can perform deletion. Again fetch the value 10 and store it under the temporary variable. Now, under the temporary variable, I am storing 10 here. After storing the value under the temporary variable, you can increment the front, which means this value is completely ignored and front has been incremented. Now, if you check whether front is equals to -1, no, front is not equals to -1. Whether your front is greater than rear, yes, we deleted these two, right. Now, if you check where your front is pointing the index position 4 and rear is pointing the index position 3, which means front is greater than rear, right. When front goes greater than rear also, means what? The stack is completely empty only. So, when the front is equals to -1 or front is greater than rear, which means the stack is completely empty, underflow condition occurs. Why? Because no more deletions can be done when the queue is completely empty. So when if it is not empty, you can go to the else part, store it under the temporary variable and increment the front. That's it. Deletion operation is done now. Thank you.